Lab number 67, hot bulbs. In today's lab, we are going to see what our challenge question is. What is the efficiency of a light bulb? Okay, so a couple things that we want to talk about is efficiency. What is efficiency? Efficiency is the ration of useful energy released by a process of the total energy absorbed by the process. And we learned that in a previous lab in this unit. Okay, so, all right, in our lab today, we are going to set up our experiment, okay? I used a graduated cylinder to measure out 12 milliliters of water into cup A of the CPUP tray. I put a foam cap on it. Okay, I put a thermometer in it and also my light bulb. I'm going to make a data table. Okay, this data table should be in your lab notebook. Okay, so we should have our cups, our volume of water. Okay, so we said our volume of water was 12 milliliters, and this is true for cup A. Okay, we don't know all this stuff yet. In cup E, okay, we are going to set up a control unit here, and our control is just going to be the same amount of water, 12 milliliters, and we are going to get the measurements of the initial temperature in degrees Celsius. So if we look at our thermometers in cup number A, okay, we have a thermometer reading of 20 degrees Celsius. And in our control unit, we are also going to have, okay, about 22 degrees Celsius. Okay, so over here we're going to put we already have the volume of water is 12 milliliters, and that's in both A and E. We don't know the time in minutes yet. The initial temperature for cup A was 20 degrees Celsius. Cup E was 22 degrees Celsius. Okay, so what we're going to do is we are going to use a hot bulb, which is an incandescent light bulb. An incandescent light bulb is a light produced by a hot object. It uses a filament that is heated by the flow of an electrical current. Incandescent light bulbs are no longer produced in the United States because of the poor efficiency rate that they do have, and now we are going to using LED and other types of lights. We also have a fluorescent light, which is a visible light produced by using higher energy light waves, which are ultraviolet, to bombard a material. Fluorescent light is used by electrons interacting with mercury vapor in a tube. A lot of times you'll see these in a garage or a work area. You'll also see them in a classroom above your head to produce light because they give you more natural light. The problem with these fluorescent lights is that they have a gas in them, so in a cold garage and you turn on your fluorescent light, you may notice that these lights do not turn on right away until they get warm because that gas has to get warmed up and get bombarded by those electrical current there. So there are some good and bad for both, using both types of light bulbs. So today we're going to use an incandescent light bulb to figure out the amount of, or find out the efficiency of the light bulb. Okay, so what I am going to do is I am going to connect a battery with our wire leads to a light bulb, okay, and we're going to time this for 3 minutes. Okay, so our time in our table there will be actually 3 minutes for both of these. Okay, get a stopwatch going here. Okay, so what I'm going to do is I'm going to hook up my battery to my leads on my light bulb and get it to shine. Okay, I'm going to time this for 3 minutes. Okay, so as I am sitting here waiting for 3 minutes, okay, we will wait for the temperature change. Okay, we talked about temperature change. Okay, so a temperature change is the final temperature, or I'm sorry, the final temperature minus the initial temperature. Okay, that will give us our temperature change. We had previously done temperature change in other labs, such as the Burning the Cheeto lab and the Measuring Calorie lab. Okay. So as soon as this gets to 3 minutes, we are going to figure out the temperature after the light bulb has been releasing energy, and this is going to help us calculate. You will also need to have this table, okay, the light bulb calculations. You will also need to have this data table into your lab notebook. So if you do not have that, you can record that. Right now we're about a minute into our experiment here, and so far looks like we're at about 21 degrees in our water with the, so you can see there that our water is absorbing the energy that is being released as heat or thermal energy by the light bulb. Okay, so we can see that some of the electricity that is coming through from the battery into the light bulb is not being used to light the light bulb, but rather than heating the light bulb. Okay, so we're approaching about 2 minutes into this experiment, okay? And we will just take another glance at the calculations now. After about 2 minutes into the experiment, we're at about 23 degrees Celsius. So we've gone from 20 to 23 degrees, so we've raised about 3 degrees Celsius. So as we sit here and we wait, we have about 30 seconds left on the old stopwatch. When we do this, we're going to want to unplug the battery from the light so that and get a recording so that we can get this as best we can. Got about 14 seconds here to go. 10 seconds. 9. You know, the big drama here. The big shebang. Okay, so we're at about time. Okay, so what we want to do is we release that, and we're going to come over here and we're going to look at our temperature change, and I got to get this so that I can see it. Okay, as long as you guys can see it there. And we're at about 24 degrees Celsius. Okay, so in our lab notebook, we're going to put that our final temperature was 24 degrees Celsius. And then now we also need to check our control, okay, and our control temperature in cup E. Okay, what do you think should have happened to the water in your control unit? Should it stay the same? Should it go up? Or should it drop? Okay, so if we come over here and we look at that, okay, we are going to see that this control unit of water is still at 22 degrees Celsius after 3 minutes. So we'll record 22 degrees Celsius into our final temperature. So now we want to do the temperature change. Okay, temperature change is the final temperature minus the initial temperature. So please record that information into the last box there, which is temperature change. Okay, so we're going to use this information, 4 degrees temperature change, our 4 degrees and our 0 degrees in our next table. Okay, so what we're going to do now is we are going to calculate the thermal energy released in calories. Okay, then we're going to figure out the electrical energy absorbed in calories, the thermal energy output percent, and the light efficiency percent. So, energy released, okay, which is calories, is a temperature change times the mass of the water. Okay, remember that a 1 milliliter of water weighs 1 gram. So how many grams, or what was the mass of our water in milliliters? If you refer back, it was 12 milliliters. So now we are going to figure out, okay, first of all, our temperature change for cup A was 4 degrees, and the mass of the water was 12 grams, okay? So please figure out the energy release calories. This is also something that we did in the Burning the Cheeto lab. Okay, so you're gonna figure out the energy released for cup A and cup E at this time. Okay, number 12. We're going to figure out the electrical energy absorbed in calories. So the electrical energy absorbed calories equals the time the bulb was then lit in minutes times 27 calories per minute. So if you remember from our table that we had 3 minutes for each of those times 27. So you need to take 3 times 27, and that will give you your electrical energy absorbed in calories, which it needs to go here. Number 13, we are going to calculate the percent of thermal energy produced by the light bulb using the following equation. Thermal energy output in percent equals the thermal energy released divided by the electrical energy absorbed times 100. Okay, I know it has that percent sign there, but that's just letting you know that this number is percent. Please do not times this times 100%. It is just times 100. Okay, so the thermal energy released was this number right here in this first column. Your electrical energy absorbed, which was here, which we got in step number 12, times 100. So this number divided by this number times 100 will figure out the thermal energy output percent. Okay, please figure that out. The last step, number 14, is the light efficiency percent equals 100%, which is just going to be 100. Again, we're not going to use a percent sign, just 100 minus the thermal energy output, which is in the third column here. So whatever this number is, you're going to take 100 minus this number here to give you the light efficiency percent. Okay. So if say we have 100% is the most we can have. Okay. So if the light produces 80% heat, okay, so if you take 100 minus 80, then 20% of that is light, was devoted to light. So the efficiency rate is 20% of the light. So 80% of the energy is being released into heat, and only 20% is light. Okay, so this has a 20% efficiency rate. Okay, so is that good or bad at this point in time? Okay, this is lab number 67. Hot bulbs. You will now answer analysis questions 1 through 5.